Hello friends, in the last video we have seen what is the meaning of composite function. In that case we have seen composite function means function of a function. And to find out the derivatives of composite function we have proved one theorem which is called a chain rule. In the chain rule what is given to us? Y is differentiable function of u. It is given to us that y is differentiable function of u and u is differentiable function of x. Then we are not able to directly differentiate y with respect to x. That's why we are using chain rule, and this chain rule says that value of dy upon dx means derivative of y with respect to x is derivative of y with respect to u into derivative of u with respect to x. Now using this chain rule we are going to prove some standard formulas to find out derivative of composite function. So already we have prepared one list of all these formulas. We will prove any one of these formula, and same method is applicable to prove the remaining all formulas. So let us consider one trigonometric function. Let us try to prove this formula. So what is given here? Y is equals to sine f of x. If y is equals to sine f of x, then we have to prove that its derivative dy upon dx is equals to, already we know that what is derivative of sine x? Derivative of sine x is cos x. In the same way, derivative of sine f of x will be what? Cos f of x. And then we have to multiply by derivative of f of x, and derivative of f of x is denoted by what? F dash of x. Such method we are using to find out derivative of composite function, because here sine is not the function of variable, it is the function of function. So well, let us try to prove this formula, and later on we will solve the example applying all these formulas. So proof. So here it is given to us that y is equal to sine f of x. So I am supposing that let u is equals to f of x. So this implies that if u is equals to f of x, then its derivative, if we are differentiating both sides with respect to x, so what we will get here, du upon dx is equals to derivative of this u with respect to x will be du upon dx, and derivative of f of x will be equals to what? F dash of x. So value of du upon dx is known to us, du upon dx is known to us. So therefore, now if we are denoting this f of x by what? U, then what will the value of y? Y will be equals to sine u, because f of x we have denoted by what? U. So differentiate it with respect to u. So what is derivative of y with respect to u? Dy upon du is equal to, and what is derivative of sine u with respect to u? We know that derivative of sine x with respect to x is cos x. In the same way, derivative of sine u with respect to u will be equals to cos u. So which is equals to cos, keep it as it is, u I am replacing by its value. What is the value of u? F of x. U is equals to f of x. Let us denote this value say by equation number first and this value by equation number second. So now we are applying chain rule. So we have chain rule. What is that chain rule? Dy upon dx will be equals to dy upon du into du upon dx. Now we are substituting the value of dy upon du. What is the value of dy upon du? According to equation number second, its value is equal to cos f of x. So its value is equal to cos f of x into du upon dx. What is the value of du upon dx? According to equation number first, its value is equal to f dash of x. So here we have got our required result, dy upon dx is equal to cos f of x into f dash of x. Now try to understand here. Now what method we have used, how we have made the use of chain rule, that is not the important part. So important part is what is the formula here we have got. Instead of x, if any another term appears, at that time we can say that it is composite function. What is our original formula? Sin x. Its derivative is cos x. Instead of x, any another term appears, at that time we can say that it is composite function, and we will consider this term as f of x. And what is derivative of sin f of x? Will be cos f of x, and later on multiply by what? Derivative of this f of x, means f dash of x. So all these formulas we are going to prove using same formula. Again, try to understand what is our first formula. First for standard formula is x raised to power n. First standard formula is x raised to power n. If y is equal to x raised to power n, then its derivative dy upon dx will be equals to, first take this power as an coefficient and decrease power by 1. So this is the simple formula to find out derivative of x raised to power n. But now instead of x, if f of x is there, sorry, here y is equals to f of x raised to power n is there. Means if n is replaced by x is replaced by any another term, we will consider it as what? F of x. Then what result we will get here in the derivative? What we will get here? So what is our formula? First take this power as an coefficient. So here also we are taking power of f of x as an coefficient. Then instead of x here f of x is there. So on this side also replace f of x by what? F of x. So f of x raised to power n minus 1. Just simply here x is replaced by f of x. So on this side also x will get replaced by f of x. But lastly we are multiplying by what? F dash of x. So into f dash of x. In every case we have to use the same method. If x is replaced by f of x, on this side also replace x by f of x. Lastly multiply by derivative of f of x. Means again we are writing the same formulas, but only x is replaced by what? F of x. Such functions are called as composite function. Prepare this list of all formulas. Already you know the 4 rules also. Applying this, now we are solving an example from first exercise. Now we are starting first exercise. In question number first, total 6 examples are given to us, and all these 6 examples are related with algebraic function. And we will have these 3 formulas to find out derivative of algebraic function. What is our original formulas? First original, instead of x, x raised to power n is there. Then second formula is 1 upon x raised to power n. And third formula is under root x. These are our standard formulas. But as a stand we are studying about what? Composite function. Composite function means function of a function. If x is replaced by another term, so we are considering that another term as f of x. And then we are applying this formula to find out its differentiation. Again, let us revise these formulas. Here it's differentiation of x raised to power n. First take power as an coefficient and decrease power by 1. Again, derivative of 1 upon x raised to power n is minus n upon x raised to power n plus 1, and derivative of root x is 1 upon 2 root x. Now only x will get replaced by what? Another term. At that time we are applying these formulas. Observe the example number first. In example number first, one function is given to us. This function we have denoted by y. Now we are differentiating it with respect to x. So differentiate it with respect to x. So derivative of y is denoted by dy by dx. But whenever we are finding differentiation, we have to observe the given function very carefully. And later on you have to decide which formula we are able to apply to find out differentiation. Now as it stand here, n, power n is given to us, means term is in the form of this formula. Means the example is in the form of f of x raised to power n. So this whole term will be your f of x. So is it clear? First important thing that you have to observe the given function and you have to decide which formula can be applicable here to find out the differentiation. So as it stand here, the terms are in the form of first formula f of x raised to power n. So already we have underlined here what will be f of x. So according to this formula, first take this power of f of x as an coefficient. So we have taken here power, this power n we have taken as an coefficient. Then decrease power of f of x by 1. But here what is f of x? This whole term is f of x. X cube minus 2x minus 1. We are decreasing its power by 1. So what is first step? First step to take the power as an coefficient and decrease power of f of x by 1. Into what? F dash of x means derivative of f of x. So derivative can also be denoted by what? D by dx. While solving the example, derivative we will denote by d by dx. Then derivative of what? F of x. What is f of x here? F of x is x cube minus 2x minus 1. Remaining part is simplification part. 5 keep it as it is, this x cube minus 2x minus 1 raised to power 4 keep it as it is. Now we are finding its differentiation. What is derivative of x cube? Derivative of x cube, it is in the form of x raised to power n. So in this case, first take the power as an coefficient and decrease power by 1. And derivative of minus 2x will be equals to what? Minus 2. And derivative of this constant term will be equals to 0. Now see, why the derivative of minus 2x will be minus 2. That also we will already, I think if you have gone through the example in class 11, you are very well known with it. But till we will discuss it by considering one example. So let us suppose that one function is there, y is equals to say 5x, and we are finding its differentiation dy by dx. Whenever we are finding differentiation, at that time we are applying product rule. If product of two term is there, here also product of two term is there. So that's why while finding differentiation we are applying product rule. So according to product rule, keep first term as it is and derivative of what? Second term. What is second term here? X plus second term as it is into derivative of first term. What is first term here? 5. So which is equal to 5, keep it as it is. Now here to find out derivative of this x, first take its power as an coefficient. Here nothing is the power, means what is the power? 1. So first we are taking this power as an coefficient, then decrease power by 1. So plus x, keep it as it is. What is derivative of constant function? Derivative of constant function will be equals to 0. So which is equal to, we know that any number raised to power 0 will be equals to 1 according to laws of exponent. 1 into 1 into 5 will be 5. And here 0 into any term is 0. So not necessary to write down 0. So now we are not applying this method while solving the example. Now what result we have got, that observe here. If the function is in the form of 5x, at that time whatever, if the power of x is what? 1. At that time whatever may be the coefficient of x will be its derivative. Don't apply this product rule while finding differentiation. Just simply remember that whatever may be the coefficient of x will be its derivative. Now instead of x, if suppose that the function is y is equal to say 10 sine x, at that time while finding derivative, keep this constant term as it is. Don't apply product rule. If in the example product of constant term and term of variable is there, in such cases not necessary to apply product rule. Keep the constant term as it is and derivative of sin x will be equals to what? Cos x. Simply using this method we are able to find out differentiation. Here what result we have got? Whatever may be the coefficient of x will be its derivative. What is coefficient of x here? Minus 2 will be its derivative. So hope the idea is clear. Now let us try to solve the example number 2. Again one function is given here. To find out its differentiation, we have to observe the function and later on we have to decide that which formula can be applicable to find out the differentiation. Here if you observe here, again the function is in the form of what? F of x raised to power n. Means again we have to apply the same formula to find out the differentiation. So let us apply this formula to find out differentiation. According to this formula, first take this power of f of x as an what? Coefficient. So what is power here? 5 by 2. We have taken that power as an coefficient. Then decrease power of f of x by 1. What is f of x here? 2x raised to power 3 by 2 minus 3x raised to power 4 by 3 minus 5. If we are decreasing power by 1, means 5 by 2 minus 1 will be equals to 3 by 2. So new power will be here equal to 3 by 2. Now we have taken first power as a coefficient, then decrease its power by 1 into what? Into f dash of x. F dash of x means what? Derivative of f of x. So derivative we are denoting by d by dx into f of x. Is it our f of x? So here f of x is 2x raised to power 3 by 2 minus 3 into x raised to power 4 by 3 minus 5. Okay. So here nothing is there to simplify. So keep this term as it is, 5 by 2 as it is, 2x raised to power 3 by 2 also as it is, minus 3 into x raised to power 4 by 3 minus 5 raised to power 3 by 2. Keep this first term as it is. Now we are finding its differentiation. Now 2 is a constant term, keep it as it is. Now we are finding its differentiation. To To find out its differentiation, observe this term. It is in the form of x raised to power n. X raised to power n. According to this formula, first take this power as an coefficient. So we have taken 3 by 2 as an coefficient and decrease power by 1. So if you are decreasing power by 1, 3 by 2 minus 1 will be equals to what? 1 by 2. Minus, now we are finding derivative of second term. So in this case, if you observe, terms are connected by what? Minus. Minus means we are applying subtraction rule. Already we have seen the subtraction rule. First find out derivative of first term. If minus is there, keep minus as it is. Then find out derivative of second term. So here 3 is a constant term, keep it as it is. Now this term is in the form of x raised to power 4 by 3 is in the form of x raised to power n. According to this formula, first take this power 4 by 3 as an coefficient and decrease its power by 1. So 4 by 3 minus 1 will be equals to 3. 4 minus 3 will be equals to 1 by 3. So new power will be equals to 1 by 3 here. And lastly, find out derivative of minus 5. Minus 5 is a constant term and we know that derivative of constant term is 0. So not necessary to write 0 here. Now differentiation is completed. So if possible to simplify, simplify it. Otherwise keep it as it is. Let us check, is it possible to simplify here. So 2 and 2 will get what? Cancel. Here 3 and 3 will also get what? Cancel. So which is equals to 5 by 2, keep it as it is. 2, keep this whole term as it is. 2 into x raised to power 3 by 2 minus 3 into x raised to power 4 by 3 minus 5 raised to power 3 by 2. Okay, so observe the remaining term. 3 keep it as it is. X raised to power 1 by 2. 1 by 2 means what? Square root. So it can also be written as square root of x, or if you are writing x raised to power 1 by 2 till you will get the same mark here. So its meaning is one and the same. Minus 4 as it is, x raised to power 1 by 3, keep it as it is. Otherwise it can also be written as what? Cube root of x. So in this way, now we are nothing is there to simplify. So this will be our required differentiation. So let us try to solve the example number 3. So here given function is under root x square plus 4x minus 7. So to find out its differentiation, means in every example while solving while finding the differentiation, you have to check that this term is in the form of which formula. So here it is in the form of under root f of x, isn't it? It is in the form of root f of x. Means to find out its differentiation, we have to apply this formula. So let us find out its differentiation applying third formula. So its derivative dy upon dx is equals to, according to this formula. So again observe here, under root f of x. This whole term is nothing but f of x here. And what is derivative of under root f of x? 1 upon 2 root f of x. So its derivative is 1 upon 2 root f of x. What is f of x? X square plus 4x minus 7 into derivative of f of x. What is f of x here? X square plus 4x minus 7. Just now we have substituted the value in this formula. This whole term is considered as what? F of x. Function is in the form of under root f of x. So its derivative is 1 upon 2 root f of x into derivative of f of x. Now let us differentiate it. So which is equals to 1 upon 2 under root x square plus 4x minus 7, keep it as it is. Nothing is there to simplify here, into derivative of this term. What is derivative of x square? It is in the form of x raised to power n. First take this power 2 as an coefficient and decrease power by 1. So here new power will be 1. And what is derivative of plus, keep it as it is. What is derivative of 4x? Just now we have seen that whatever may be the coefficient of x will be its derivative. So what is coefficient of x here? 4. 4 will be its derivative. And lastly, derivative of constant term is 0. So not necessary to write 0 here. Now 2x plus 4 into 1. Parallelly, can I take 2 common from these two terms? If we are taking 2 common, so here remaining term is x plus 2. Just simply we are taking 2 common from these two terms, and in the denominator 2 under root x square plus 4x minus 7, keep it as it is. So here 2 and 2 will get cancelled. After cancelling 2 from numerator and denominator, in the numerator we will get x plus 2 and in the denominator we will get under root x square plus 4x minus 7. Now nothing is there to simplify, so this will be our required differentiation. See in this fourth example, given function is under root x square plus root x square plus 1. So let us differentiate it. So dy upon dx is equals to find out its differentiation, observe that function is in the form of what? Under root f of x. This whole term is your f of x. Under root f of x means here we are able to apply third formula to find out the differentiation. According to this formula, its differentiation is 1 upon 2 under root what? F of x. What is your f of x here? X square plus under root x square plus 1. Okay. Into derivative of f of x. What is f of x here? F of x is x square plus under root x square plus 1. Okay, just we have substituted the value in the third formula. So which is equals to 1 upon 2 under root x square plus under root x square plus 1, keep it as it is. Now we are finding its differentiation. To find out differentiation, again we have to apply the standard formulas. Observe that here two terms are connected by what? Plus. So in such case we are applying addition rule. According to addition rule, first find out derivative of first term, plus keep it as it is, then find out derivative of second term. So let us apply here addition rule. According to our standard formula, derivative of x square is what? 2x. Just simply take power as an coefficient, decrease power by 1. Plus, now we are finding derivative of this second term. Whenever we are finding differentiation, our aim is to apply standard formulas. So this term is in the form of what? Again it is in the form of root f of x. But here f of x is what? X square plus 1. So under root, this whole term can be considered as f of x. According to this formula, its differentiation is 1 upon 2 root f of x. What is f of x? X square plus 1 into derivative of f of x. What is f of x? X square plus 1. So which is equals to here 1 upon 2 under root x square plus under root x square plus 1, keep it as it is, into. So now here 2x also as it is, plus what is derivative of x square? 2x. And what is derivative of this 1? 0. Means what is derivative of this whole term is 2x. 2x plus 0. Derivative of x square is 2x. Derivative of 1 is 0. So 2x plus 0 will be 2x. And 2x into 1 will be equals to 2x. Divided by 2 under root x square plus 1. In this way differentiation is completed. If differentiation is completed, remaining part is simplification part. Let us simplify it. Here 2 and 2 will get what? Cancel. If you will observe the numerator very carefully, can I take x common from the numerator? If we are taking x common from the numerator, so here we will get x divided by 2 under root x square plus under root x square plus 1. Now if we are taking x common, so here remaining term is 2 plus x already we have taken common, so here remaining term is 1 upon under root x square plus 1. So now here keep it as it is, otherwise you are able to take cross multiplication also. Let us see what result we will get if we are taking cross multiplication. X upon 2 under root x square plus under root x square plus 1, keep it as it is, keep this first term as it is. Here we are taking cross multiplication. If we are taking cross multiplication, see what we will get here. 2 under root x square plus 1 upon under root x square plus 1. So will be the required differentiation here. Now let us try to solve the next example, example number 5. In this example, if you observe the given terms very carefully, here in the numerator 3 is given to us, in the denominator 5 is given to us. Here cube root of 2x square minus 7x minus 5 raised to power 5 is given to us. Means we are able to simplify this expression. First simplify it and later on find out its differentiation. So in this case, already we know that, suppose that here cube root of x raised to power 5 is there. Then according to laws of exponent, it can be written as x raised to power 5, keep it as it is, and this cube root can be replaced by raised to power what? 1 by 3. Then 5 into 1 by 3 will get what? X raised to power 5 by 3. So we are simplifying it using laws of exponent. So using laws of exponent, this expression can be written as 2x square minus 7x minus 5 raised to power 5, and since cube root of is there, means cube root means raised to power 1 by 3, and 1 by 3 into 5 will be what? 5 by 3. Okay, so just we are simplifying it. Now let us try to differentiate it. Whenever we are finding differentiation, we have to observe the given function, and later on we have to decide which formula can be applicable here. So 3 by 5 is a constant term. So keep this 3 by 5 as it is. Okay, constant term, keep it as it is. Now if you observe the given function, is it in the form of 1 upon f of x raised to power n? 1 upon f of x raised to power n means this whole term should be your what? F of x. 1 upon f of x raised to power n. So we are applying second formula to find out differentiation. According to second formula, what we will get in the numerator? We will get minus n. N is nothing but this power. So here its differentiation will be equals to minus n. N is what here? 5 by 3 divided by f of x raised to power n plus 1. What is your f of x? This whole term is f of x. That is 2x square minus 7x minus 5. According to this formula, we are increasing power by 1. As this time, what is the power? 5 by 3 plus 1. So what we will get here? 3 ones are 3, 3 plus 5 will be 8. Means here addition will be equals to 8 by 3 into derivative of f of x. Into what? F dash of x. F dash of x means what? Derivative of f of x. Into derivative of f of x. What is f of x here? This whole term is f of x. That is 2x square minus 7x minus 5. Okay. So which is equals to, so here if you observe very carefully, this 3 by 5 and 5 by 3, can I say that these two terms will get cancelled? 3 and 3 will get cancelled, 5 and 5 will get cancelled. Means in the numerator remaining term is minus 1. Keep this term as it is. 2x square minus 7x minus 5 raised to power 8 by 3 as it is. Now we are finding its differentiation. So let us differentiate it. 2 is a constant term, keep it as it is. What is derivative of x square? Derivative of x square is 2x. So 2x minus, what is derivative of 7x? Whatever will be the coefficient of x will be its derivative, and derivative of this minus 5 means derivative of constant term will be equals to 0. So which is equals to, keep this minus as it is, 2 into 2x will be equals to 4x minus 7. Just we are taking multiplication of these two terms. In the denominator, keep this term 2x square minus 7x minus 5 raised to power 8 by 3. Keep it as it is. So this will be your required differentiation, but till if you want to simplify, we are able to multiply by minus to both the terms in this bracket. So if we are multiplying by minus, minus into minus 7 will become plus 7, and minus into 4x will become minus 4x divided by 2x square minus 7x minus 5 raised to power 8 by 3. Keep it as it is. Again, see here, whenever you are finding differentiation, first observe the given function very carefully, and later on decided that which formula can be applicable here to find out the differentiation. If we are solving near about 20-30 example, easily you are able to analysis that which formula can be applicable, because how many formulas are there? At this time only maximum 15 formulas are there to find out the differentiation. See here, this is the given function which we have simplified, and here we have started its differentiation. So here dy by dx is there, derivative of y we are denoting by dy by dx, and here we are finding its differentiation applying which formula? 1 upon f of x raised to power n. Okay. So let us try to solve the sixth, means last example from question number first. Again, if you observe, it is also derivative of algebraic function. So differentiate it with respect to x. Differentiate it with respect to x. So derivative of y will be dy by dx. On this side, to find out the differentiation, first observe the term is in the form of which formula. So if you observe this, if you are considering this whole term as f of x raised to power 5, means this whole term is what? Your f of x. Now we are applying first formula to find out its differentiation. According to this formula, first take power as an coefficient. What is power of f of x here? 5. So if you are taking power as an coefficient, then decrease power by 1. So here under root 3x minus 5 minus 1 upon under root 3x minus 5 raised to power 4. Just simply we have taken power as an coefficient, then decrease power by 1. into what? F dash of x. F dash of x means what? Derivative of f of x. So this is your f of x. D by dx of under root 3x minus 5 minus 1 upon under root 3x minus 5. Okay. So here nothing is there to simplify. So keep this term as it is, which is equal to 5 into under root 3x minus 5 minus 1 upon under root 3x minus 5 raised to power 4. Means keep this first term as it is. Now we are finding its differentiation. While finding differentiation, we are using the standard formulas. Here terms are in the form of u minus v. Means to find out the differentiation, apply subtraction rule. And subtraction rule says that what? First find out derivative of first term, minus keep it as it is, then find out derivative of second term. Now we are finding derivative of first term. To find out its derivative, again we are applying standard formula, and this term is in the form of third formula under root f of x. According to this formula, its differentiation is 1 upon 2 root f of x. What is f of x here? This 3x minus 5 into its derivative, into derivative of f of x, into derivative of f of x. This f of x is here 3x minus 5. Hope you are getting it. It is in the form of under root f of x. So its derivative is 1 upon 2 root f of x into derivative of f of x. Now minus keep it as it is, and let us try to find out differentiation of this second term. So observe the differentiation of second term. Again, to find out its differentiation, we have to check that the term is in the form of. Term is in the form of what? 1 upon f of x. This term I am considering as f of x. 1 upon f of x raised to power. Square root means what? Raised to power 1 by 2. Isn't it? Square root means raised to power 1 by 2. It is in the form of 1 upon f of x raised to power n. But n is what here? Square root means raised to power 1 by 2. So according to this formula, its differentiation is minus. Minus and this minus will become what? Plus. N means what? Power. Root means what? Raised to power 1 by 2. Divided by, increase the power of f of x by 1. What is f of x? 3x minus 5. And its power as it stand is root means 1 by 2. And if you are increasing power by 1, means what we will get? 1 by 2 plus 1 is 3 by 2. Into f dash of x, means into f dash means what? Derivative. Derivative can also be denoted by d by dx. Derivative of f of x. F of x is what here? 3x minus 5. Okay. So which is equal to, again let us simplify it. So 5 keep it as it is, under root 3x minus 5 minus 1 upon under root 3x minus 5 raised to power 4 keep it as it is into. So now what is derivative of first term? Derivative of 3x is equal to 3. And derivative of constant term is equal to 0. Means derivative of this whole term is 3. And 3 into 1 is 3. So here we are getting 3 upon 2 under root 3x minus 5. Here plus keep it as it is. Now again we are finding differentiation of this term. Derivative of 3x is 3. And derivative of constant term means 5 is 0. Means derivative of whole term is 3. And 3 into 1 by 2 will be equals to what? 3 by 2. In the denominator, 3x minus 5 raised to power 3 by 2, keep it as it is. Now, if you will observe, can I take 3 by 2 common from both the term? If we are taking 3 by 2 common, so here we will get 5 into 3 by 2. Keep this term as it is, under root 3x minus 5 minus 1 upon under root 3x minus 5 raised to power 4. Keep this term as it is. Now we have taken already 3 by 2 common from both the term. And if you will observe the remaining term here, it will be 1 upon 3x minus 5 raised to power. Square root can be replaced by 1 by 2. Plus 3 by 2 already we have taken common, 1 upon 3x minus 5 raised to power 3 by 2. If you will observe the power here, base 3x minus 5, here also 3x minus 5, base are same. But powers are different. What is power here? 1 by 2 and here 3 by 2. Now, if you will observe, 3 by 2 is greater comparatively to 1 by 2. Check whether we are able to get same term in this here in the denominator. To get the same term in the denominator here, 1 by 2 plus 1 will be equals to what? 3 by 2. Means we have to multiply by 3x minus 5 to denominator also and to numerator also, so that denominator becomes what? Equal. If denominator becomes equal, easily we are able to take the addition of numerator. So which is equal to, here 3 5s are 15. 15 upon 2. Keep this first term as it is, under root 3x minus 5 minus 1 upon under root 3x minus 5 raised to power 4. Okay. Now what we are doing here, to make the power same, we are multiplying here by 3x minus 5. So if I am multiplying by 3x minus 5, what we will get then? 3x minus 5. Already if I am multiplying by 3x minus 5, and already here 3x minus 5 and 3x minus 5 raised to power 1 by 2, means we are taking addition of power, 1 plus 1 by 2 according to laws of indices. It will become 3x minus 5 raised to power 3 by 2. So that denominator of both the term will become what? Same. See what we'll get if you are multiplying to numerator by 3x minus 5. Definitely what we'll get in the denominator? 3x minus 5 raised to power 3 by 2. Denominator will become equal if I am multiplying here, multiplying to numerator and denominator by 3x minus 5. If I am multiplying here by 3x minus 5, 3x minus 5 plus 1 will be equals to 3x minus 4 will be the required differentiation here. So in this way we have completed question number first. Example in question number first, 6 examples are there which already we have solved. Now in question number 2, examples are related with trigonometric function, exponential function and logarithmic function. Try to prepare the list of standard formulas, and remember that 4 important rules are also there which we are using while finding differentiation. Which 4 rules? Addition rule, subtraction rule, product rule and quotient rule. Means now you should have to know the standard formulas and 4 rules to find out the differentiation. In the next video, we are starting question number 2 from the same exercise first.